Let's solve a kinematics problem involving derivatives. We have a particle moving along a straight line, where its distance s in meters is given by the equation s equals 1/2 t cubed plus t squared plus 4t, where t is in seconds. We need to find the velocity and acceleration after 5 seconds. Let's visualize this motion. Here's the position versus time graph of the particle. As we can see, the curve is a cubic function, showing the particle's position changes nonlinearly with time. To find the velocity, we need to take the derivative of position with respect to time. Using the power rule, the derivative of 1/2 t cubed is 3/2 t squared, the derivative of t squared is 2t, and the derivative of 4t is just 4. For acceleration, we take the derivative of velocity with respect to time. Again, using the power rule, the derivative of 3/2 t squared is 3t, the derivative of 2t is 2, and the derivative of 4 is 0. Now let's find the values at t equals 5 seconds. For velocity, we plug in t equals 5 into our velocity equation. This gives us 3/2 times 25 plus 2 times 5 plus 4. Computing this, 37.5 plus 10 plus 4 equals 51.5 meters per second. For acceleration, we plug in t equals 5 into our acceleration equation. This gives us 3 times 5 plus 2. Computing this, 15 plus 2 equals 17 meters per second squared. Therefore, after 5 seconds, the particle's velocity is 51.5 meters per second, and its acceleration is 17 meters per second squared.